Here you are looking at a side view of an eye where light is focused perfectly on the seeing layer of the eye, which is called the retina. Ideally, when we look at a distant object, we have an exact match between the optical power of our eye and eye length, resulting in a sharp image just like a well-focused camera. But many of us do not have this luxury. In a myopic or nearsighted eye, there is a mismatch where the optical power of the eye is too high for the eye length. As a result, the focus hits in front of the retina, causing distant objects to appear blurry. This is a product of the eye growing too long, and that's what's shown in the figure on the right. Myopia's prevalence has been increasing in the United States and even more so in Asian countries. This increase in prevalence has become a worldwide public health concern, and it's projected that 50% of the world's population will become myopic by the year 2050. We can correct for the focusing problem of myopia just like bringing the camera into focus with glasses, contact lenses, and/or refractive surgery to change the shape of the front surface of the eye. But unfortunately, there is no real cure for myopia. However, there are several optical treatments that slow its progression, either by changing the shape of the front surface of the eye or changing the defocus that is experienced on the back of the eye. In addition, there are common eye drops called atropine that are used for other purposes but also have some myopia control effects. None of these methods offer full control of myopia or switch off myopia progression, so they all have advantages and disadvantages. If myopia can be corrected or controlled, then why is it a pressing public health issue? Myopia is associated with many vision-threatening complications. These are various complications of myopia. This is what your eye doctor may see when they look in the back of a myopic eye. One of these complications is glaucoma, which is a problem of having too high of a pressure inside the eye that damages the nerve of the eye indicated here by the red arrow. But the eye pressure, which is what we refer to as intraocular pressure, also has a role in normal eye enlargement and potentially an enlargement in myopic eyes. As an eye grows, the outer white wall of the eye, called the sclera, is being remodeled, and the pressure inside the eye helps the eye enlarge, just like blowing up a balloon. In normal eye growth, this is a very finely tuned process, so we get just the right eye length for our optics. In myopia, the eye keeps growing longer, and in glaucoma, we have a problem that the pressure is too high and may cause damage to the nerve in the back of the eye, which is shown in side profile leaving the eye here. In this study, we are interested in testing the hypothesis that lowering eye pressure would slow down eye elongation and reduce the risk of developing eye complications such as glaucoma. In our experiment, we are using the guinea pig as an animal model. We induce myopia in one eye using a white plastic cover that we call diffuser. This method is a bit like young babies having a cloudy lens or front part of the eye, which makes their eyes grow longer and become myopic. We cover the guinea pig's eyes for a total of 12 weeks. After the first week, the myopic guinea pigs are divided into two groups. Myopic eyes of the first group received drops with no active ingredients or what's called artificial tears. And these are considered our control animals. The myopic eyes of the second group receive a drug that is known to lower eye pressure in humans and is used to treat glaucoma. Weekly measurements are performed on the two groups to track intraocular pressure, the severity of myopia, and eye length. And here are some videos showing how we perform these measurements. And here, I am demonstrating how to measure intraocular pressure using an instrument called a tonometer. Next, I measure the severity of myopia using a piece of equipment called the retinoscope. And finally, I measure eye length using an ultrasound system. So what did we find? When we put the diffuser on the eye and gave the guinea pigs artificial tears, the eyes became elongated, which is exactly what we expected to see. When we instead adding pressure-lowering drops to the covered eyes, those eyes did not only have less pressure, but also were less elongated. And now, I'm going to share with you some of my results. This graph shows the change in eye length in the two groups throughout our 12 weeks treatment period. The eye length in the control group using artificial tears and indicated by the blue line is growing longer. And the eye length in the group treated with the eye pressure lowering drops and indicated here by the red line is staying close to baseline. The impact of a difference of this magnitude translates into the difference of needing very thick corrective lenses versus much thinner lenses or not needing glasses at all. We have a very promising pilot study that suggests that a drug that is already in clinical use can slow eye elongation and control myopia. Because this drug is already FDA approved, it may reduce the time it will take to be translated to human clinical trials. Thank you.